Okay, everybody. Well, welcome to the wonderful world of distance learning. I'm actually going to make this video partly because we are doing distance learning and partly because I should have made this years ago. So today we're going to be talking about the relationship between magnets, these wonderful things right here, and the components of the Bohr model of the atom. So here we go. First of all, let's do a little bit of review real quick on what is the Bohr model of the atom. Okay, so if you've done the build an atom PhET, okay, and I'll make sure that I write that down. If you've done the build an atom PhET, you've been exploring the Bohr model of the atom. Now, in that model, there were some parts, okay? First off, parts. You had protons, and they are positive, okay? And at the same time, you had neutrons that were neutral. Well, okay, here's the thing. If you put those together, if you combine them, positive plus neutral makes positive still. Okay, and if you put those together, they are in the nucleus of the atom. Now, there's also electrons, and those are negative. And if I may, here's the basics of the Bohr model of the atom. Your positive nucleus, dunk, right there. Your negative electrons, dunk, right there. Now, the electrons are in different levels at different distances from the nucleus. Dunk, right there. Okay, so you don't just put electrons in one location, you put them in locations that increase in distance away from the center of the atom. And if you remember, you can actually get up to 2 electrons in that first ring, and then 1, 2, 3, 4, 5, 6, 7, 8 electrons in the second ring, and then 1, 2, 3, 4, 5, 6, 7, 8 in that third ring, and so forth. Now, representing an electric charge with magnets. Okay, so I've got some magnets here. Actual, honest-to-goodness magnets. Got a magnet that has a little positive sign, magnet that has a little a negative sign. Now, attraction is when objects are pulled together, and repulsion is when they push each other apart. What kind of force do we have between a positive particle and a negative particle? Hey, look at that. It's attractive, right? Now, because these are magnets, if I flip them over, they turn the opposite way. Not true with protons and electrons, but here I got a positive sign, negative sign, again representing protons and electrons. What happens if I flip them this way? Still going to attract. Okay. What about if I have 2 pluses? Oh, hey. Come back here. Come back here. Okay, so do like charges attract each other? Well, positives certainly don't. They repel each other, push each other apart. What about negatives? I think you guys might see where this is going. Okay, so this is the general interaction of charged particles with each other. If they are oppositely charged, they attract. If they have like charges, if they have the same charge, they will repel. Which means, if you have a whole atom that has a positive center and then negative rings, how are those rings going to interact with the center? How are those rings going to interact with each other? So, this brings us to the second part.
Oh, I'm so glad you cleaned it up. I will come help you. Give me a moment to get... You already did? Did it get on?
Okay, so let's make this apple represent the positive nucleus of an atom. Positive nucleus of an atom. And behind that positive nucleus, or above that positive nucleus, we're going to have some electrons. And yes, I am driving a bamboo skewer into this. So if this is the, excuse me, pardon my high-tech drawings. So if this is the Bohr model, okay, what I'm about to show you is something like this. The apple at the bottom is going to represent that positive nucleus, and then everything I'm going to put on the skewer is going to represent electrons. Now, in reality, if I put one of these magnets, which are little ring magnets, if I put one of these magnets down over this skewer, it falls down because of gravity. This represents the attraction between the positive nucleus and the negative electrons. Gravity equals attraction. But what will happen if I have another segment of this electron shell? If I have another shell, will that shell be pulled, will it be attracted to this nucleus? Well, yes. If I let this next magnet go, it will fall because of gravity. But will it be attracted to the shell below? Oops. Of course, I have to make sure I got the right side going. So, are electrons attracted to each other? Do negatives attract each other? Not exactly. Kinda. No. So, if I drop this like this, and... What? See, those magnets are repelling each other because they're magnetic, but they represent these electron shells. That's why those electron shells don't all fall into the nucleus. They are pushing each other apart. They are unable to come together. Now, if I add another electron, what's going to happen to the height here? If I add another shell, what happens to the height of this shell above here? Is it going to be a higher height or lower height when I add something on top of it? Hey, you got lower, right? What happens if I put another one on? Gets lower again. And then lower again. And as you put more on top, you see what happens to those inner rings. So, the question, how do magnets represent the parts of the Bohr model? Okay. Now, this would be normally a hands-on thing that I do in class, but since we are doing this by distance, it's not. Hopefully I'll keep this video and you'll get the chance to do this hands-on yourself if and when we meet together again. Thanks. Bye.